Because hydroxide is commonly found inside of insoluble salts, it's a common question to include pH calculations inside of our determination if, say, a precipitate will form and other types of questions. So with this, we give you an initial concentration of iron 3 plus in solution, and we're interested in if a precipitate will form at 2 different pH values. And really in this case, all the pH is just a fancy way of telling us what our concentration of hydroxide is. It's kind of nice though because we have pH meters and it's something that we can measure pretty readily. But in terms of our calculations that we've done in the past with insoluble salts, really all this is just a couple of steps away from our concentration of hydroxide. So with this, iron 3 plus forms an insoluble salt with hydroxide, FeOH3, and the KSP for that insoluble salt is 4 times 10 to the minus 38, so it's fairly insoluble. So what we're going to look at is with this first pH value, what's going to be the concentration of hydroxide, and the question is will a precipitate form? So we need to look at the ion product, or QSP. So we have our concentration of Fe3 plus, now we want our concentration of OH minus. We can plug those into our ion product and get QSP, and then compare QSP to KSP to determine if a precipitate is forming. So for this first part, we've seen this when we were talking about acids. We have a pH. What I want to find is the concentration of OH minus. From pH, I can get the concentration of hydronium pretty easily, which is 0.01 molar. Once I have the concentration of hydronium, I then can use, say, the Kw expression to find the concentration of hydroxide. So concentration of hydroxide times the concentration of hydronium is equal to Kw, or the concentration of hydroxide is equal to Kw divided by the concentration of hydronium. So Kw is a constant. The concentration of hydronium we calculated up here, and in this expression we are adding in a concentration of hydroxide that's 1 times 10 to the minus 12, and we want to understand, is this enough hydroxide to cause a precipitate to form? So we look at our equilibria for this dissociation of our insoluble salt, and we want to come up with our solubility product. So remember, that's products divided by reactants. Our reactant is a solid, it doesn't show up, and then it's our 2 products, and remember we need to raise by the stoichiometric coefficient. So this 3 here is this 3 here, and then we plug our values in. So the initial concentration of Fe3 plus was given, the concentration of hydroxide we calculated from the pH, we multiply those through, we get a QSP of 1 times 10 to the minus 39th. And when we compare that to our KSP, which was given right here, we can see that our QSP is smaller than KSP, which means no precipitate forms. We then do the same calculation. I'm not going to go through all the steps, but at pH of 12, our concentration of hydroxide has gone up quite a bit. Now we're at 0.010 molar hydroxide. I do the same thing. I plug in these numbers into my solubility product to get the ion product, which means that we're unsure about our equilibrium state. We find QSP, and then we compare that to KSP. So concentration of Fe3 plus is a constant that doesn't change. Concentration of hydronium, I get that from the pH. I remember to raise that to the 3rd power, and we get QSP, which is 1 times 10 to the minus 9th. Now QSP is greater than KSP, which means that we are going to start forming our precipitate of our iron 3 hydroxide.